Nhce-Simet, studying in CEM department, first year MTech, and this is a paper case study on improving rural water access development performance of an indigenous low-cost filter. Nowadays, in developing countries like India, the major challenge faced is for potable drinking water. And this work is mainly on focusing on providing safe drinking water using eco-friendly natural materials for benefiting overall health. Previous studies has been conducted on various filters and also with the materials like charcoal, rice husk, which is an agro waste, tulsi and neem, which is herbs, and also with respect to moringa leaves. I have took a location where I studied for the BTech in the Mysore district, Nanjangud Taluk, Thandopura. It is a village, and I have studied more on this case study on that location. The objectives is main to identify the material suitable for development of a low-cost, environmental friendly filter to produce a prototype filter model and to evaluate the performance of filter developed for water quality. The methodology and materials consist of identifying the materials like for the preparing of casing, filter media and everything, and to prepare a prototype filter to develop a prototype filter in a eco-friendly manner. Selection of location and identification, as I have told earlier, it is a case study basically on Nanjangud Taluk, Thandopura village in the Mysore district. And water sources is river Kapila, which is in Nanjangud, and river groundwater from MIT Thandopura. Sample preparation is as per IS standards, and we have followed the complete systematic sampling in a proper point, and we have prepared samples and collected samples and transported in a sterile kit and stored in a place where it behaves in the natural condition manner and processed and for leaving it for sedimentation, like detention period is given, and for separation of the sample, and finally prepared the sample for analysis. For testing of sample, we have taken physical and chemical and continues with the results and discussions. When it comes to materials, it is mainly we have used like pebbles, rice husk, charcoal, neems, tulsi and sand. Neem and tulsi is sun-dried and charcoal is hand-activated. Neem and tulsi is dried because we cannot use it directly as a fresh because it may contain a few impurities, or even if it has washed, when water is fed, it may not give more. And this is the schematic representation. We have three models in the filter, and this is the first one and second one and third one. First layer consists of neem and the first layer, initial layer, and the water passes through neem first, and then this is the layers of the filter what we have added in the second media, and this is the third media. It is tulsi, and it is in the storage and the extraction layer. This is the trial and combination error we have obtained in the last. This is the 5.5 cm larger pebbles in the initial layer, and then with a mixture of sand and rice husk, which is mixed in 7.6 cm, and activated charcoal, which is hand activated, 5 cm of charcoal and 5 cm of gravel. And because the sand and larger pebbles and gravels are used to maintain the rate of filtration. This is the location what I have mentioned earlier, and this is the process of prototype what we have achieved in the last. This is the wheel, and he is the person we have taken for the preparation of the filter model. And this is the filter. This is the first layer with the neems, and this is the second layer with the filter media, which has all the layers what I have explained in the previous slide. And this is the storage and extraction layer with tulsi. And these were the before analysis values what we have got in the samples. Sample 1 is the river sample, and sample 2 is the groundwater sample, and this is the higher standard, and before analysis and after analysis has mentioned. We have used temperature, turbidity and TDS as a physical parameter, and pH, total alkalinity, hardness, and calcium hardness, DO, chlorides, nitrites. And when it comes to the model, we have prepared a model I have shown, but comparing cost is important as we gain the results. As it is a rural sector, what we have focused on, we have compared the cost of normal conventional candle filter with the filter what we have prepared. We have used completely the eco-friendly materials, and the casing has no cost, and the materials do not have any cost, as the materials like the Risi and neem is widely, abundantly available in every street and every house of that region. And when it comes to gravel and sand, it is abundantly available. We have river Kapila near, and we can get the sand from there. And also with respect to charcoal, we have fire heated wood what we use as a only in that area. So the total cost was about like half of the cost when it compares to the candle filter conventional. And when it comes to the analysis part and all, we took like temperature was major drop, because it has a clay property which cools, and when it comes to turbidity, it was mainly because of charcoal layer. And then when it comes to alkalinity, it was due to rice husk and clay. And total dissolved solids was because of rice husk mixture and charcoal. And chlorides and nitrites was because of the clay and also with the charcoal and rice husk mix. Because of those combination of trial and error of those layers in the filter media, we came to the conclusion that those layers helped us to also with the rate of filtration and also with the changes in the results when we change the filter media. So I like to conclude that use of these local material improved the utilization of natural disinfectant for the treatment of potable water, and also helped us to know the value what Ayurvedic had in neem and tulsi in the previous ancient stages. These efforts can uplift the socio-economic situation by solving the local problems arising in developing countries, especially in rural areas. This prototype has proved that usage of filter can break through expensive water filters, helping in creating cost-effective and sustainable solution. This references what I got was like when we studied the literature review, the potable drinking water problem was not in the ancient times. It is even today a problem in developing countries like India. So this case study was taken and prepared a prototype. This was my paper on. Thank you so much. And I would like to thank each and every person who has helped me to achieve this prototype or project or the case study completely. And thank you everyone.
Did you check the water quality of the stainless steel filter? I mean stainless steel device that you showed.
Stainless steel.
Candle.
A candle filter. Huh.
Did you compare the values between say a water?
It was a cost comparison analysis.
Cost comparison.
Huh.
Did you try checking the water quality parameter?
No, it is what we use in home, the conventional candle filter. The cost comparison was done because we have not used any other materials than natural materials. But the filtration procedure we have not done.
Maybe you could have checked the raw sample, the raw water sample. Then one sample in candle water filter.
Huh.
The other one in yours. Then you could have seen the variation.
This was based on the materials what we have used. That's why I took this challenge. So, any other questions?
So if you did not explain the results, no, we showed only the graphs. No? So as sir told, no, we could have compared one in the conventional filter and the indigenous filter.
It was mainly on the materials.
Yeah, I understand. Only understand and appreciate your work, but still for comparison.
Yeah, I
you don't
got
have
it.
a control now. Control means on the with which you are comparing your results. No? Here only sample 1 real water, sample 2
Here also the
groundwater.
legend color is see sample 1 is river water
Huh. Like this is the before filtration of sample 1, this both. Before filter and after filtration. This is before filtration of sample 2 and after filtration of sample 2. And this is the highest standard value what they have mentioned. Yeah, that legend item.
Near Balguri temple you collected.
No, Nanjangud temple we have.
Anand is also from Nanjangud.
Nanjangud temple we have. The river part what we.
But MIT is very far from Nanjangud, no? How much?
No.
10 kilometers.
Not that far, sir. Like it's almost 15 minutes of road, right?
It's next to airport.
Next to airport.
After airport.
So you check this calcium hardness before it showing 600 and almost 10 times drop in the after.
Yeah, like we tried and errored it for the filter layers, right? And due to the continuous changes in the filter media, we got those results.
The same thing is not being said for that sample 1, 700 to 416.
Yeah, when we used the samples, it was from different time of sampling, and this was from different type of time of sampling. And with the filter media also, it took a few changes and
Filter media was the same, right?
means I told about rate of filtration part, because this had more what we say turbidity also, and this was having less turbidity.
How did you measure the DU? Result of
That modified Winkler's method, like laboratory procedures. Everyone was like IL 105.
So you fixed the sample first.
Yeah, we have to